So I'd like to introduce our last speaker before the lunch break, Biosafety Cabinet certification. So going into biocontainment next. Two global standards that influence this, NSF 49 and EN 12469. And Iván Kaliman from Kauai is going to take us through this presentation. We'll just let the room die down a little, Iván. There's an exodus from, and once it quietens down, you take the microphone. So okay. Welcome.
Okay, thank you.
All right. Give it. We'll just have 1 minute.
I start now. Or?
Yeah. Let me just quieten this room down. If you're leaving out of the room, would you do that quietly and rapidly, please, just so we can give the floor to Iván. Thank you.
Well, hello everyone.
Okay,
I am Iván Kaliman from Argentina. My company works in Argentina and Spain since 2008. In this presentation, I'm going to talk about why we do prefer the NSF 49 standard over the EN 12469 to certify biosafety cabinets. I have my helper because English is not my strong. All the information in these slides is based on CN workshop agreement and the Laboratory Biosafety Manual, 4th edition of World Health Organization, and of course the EN and SF standards. When we're talking about biosafety cabinet, we are talking about biocontainment. We mean protection for the people that working with the cabinet, environment, samples, and public health. If our biosafety cabinet fails in one of these points, we can compromise the people, the laboratory, the quality of our work, and consequently the public health. All Class 2 biosafety cabinets are defined as partial barrier, where the protection depends on the airflow balance and the filter integrity. This is the definition of Class 2 biosafety cabinets. The airflow that is captured by the front grill is named inflow. Is that? If it's so high, your samples will be contaminated. If it's so high, the air on the laboratory get into the workspace and contaminate the samples. If it's so slow, you can get contaminated because you lose the barrier that protects from the pathogens inside the cabinet. The downflow air is the uniform airflow that descends from the top of the workspace to the work surface and is distributed between the rear grills and the front grills. If it's so high, you could be a turbulent flow. If it's so slow, you can't reach the right velocity to displacement of the aerosols. All set points in the cabinet are defined by the manufacturer because they have done microbiological testings. The integrity of HEPA filters shall be tested using aerosol photometer method to meet the current testing standards. The objective is find leaks in the filters and the filter seals. So, what does the definition of cabinet tell us? Tell us that biocontainment depends on the three principal factors: inflow, downflow, and integrity of the filters, demonstrated by leak test. Here, the update of NSF 49 and EN 12469. It's important to emphasize that when reading the 2001 EN, is based on the text of 1992 of NSF 49. And when we're reading this standard and you compare, it's a truncated test, very truncated test of 1992. What is missing is a lot of these ambiguities that clarify the right way to do the test so as to have a reliable test on the biosafety cabinets. This timeline illustrates the changes in biosafety cabinet design concept and the technology from the 70s to the present. We have the different updates of NSF 49, the EN, and another update of NSF. Technical comparison about both standards. NSF has 192 pages that include design, construction, decontamination, performance, and testing in only Class 2 biosafety cabinets. EN have 45 pages that include the same things, but Class 1, 2, and 3 cabinets. NSF defines the all-known A1, A2, B1, B2, and C1 types of biosafety cabinets. EN doesn't define this type of cabinet, but define a generic Class 2 biosafety cabinet. This is very important because, for example, if you are testing a biosafety cabinet type B2 under EN, B2 is not defined in this standard, so as not defined the A1, A2, and C1. What we see in EN is a generic cabinet Class 2. Regarding to the technical testing to define if our cabinet is able to use without risk for us and for the samples. Downflow test. Downflow test for NSF have a tolerance of 0.025 meter per second tolerance for downflow velocity set point. Usually 21 measurement points or more are taken. NSF specifies the instrument use. We must use thermal anemometer. It's not allowed another types of anemometer with an accuracy of 0.015 meters per second. All testing procedure is described in 2 pages. In order to guarantee the uniform flow, you can never get a difference higher than 0.081 meters per second between the local point and the average. There are some exceptions when the 25% of the average is higher than 0.081 meters per second. In other hand, EN says that cabinet could be 0.25, 0.50 meters per second, allow a low number of points to take the measurement, and allows any type of anemometer. All testing procedure is described in 7 lines. Remember that downflow velocity is very important to avoid cross-contamination. Regarding to the inflow velocity, the test is very specific in NSF, having 5-page procedure, very specific about what to do, and that give us a high level of precision and repetitiveness. We have also different methods to measure the inflow velocity, but in EN, only states that the inflow velocity must be at least 0.40 meters per second, and the procedure is about 5 lines. There is no specification about the measurement technique, where the measurement should be taken, spaces between points, nor the type of instrument that should be used. Inflow is the air barrier that protects us from the escape of pathogens and protect the samples to be contaminated from the laboratory air. Leak test. In ENSF, the leak testing is very specific about how to measure the upstream aerosol concentration to have to take the downstream concentration and to have the penetration rate to conclude if the filter have a leak or not. NSF doesn't allow to do this test with particle counter. Instead, the EN instruction contradicts the current standards regarding to the method and allows to be done with particle counter, but this is not according to the method expressed in the ISO 14644 part 3. Or the technical guide for leak testing in EPA filter IEST 34. Bear in mind the right method with particle counter should take around 20 minutes per filter, and also most leak cannot be detected. The small leak is very difficult to detect with a particle counter method. Okay. About the alarms, that is very important, the alarms in the biosafety cabinet. There are different types of alarms according to the what cabinet we have. If we have an A2 cabinet, have different alarms than B1 or B2 or C1 cabinets. NSF is very rigorous on the alarm testing. It has 4 pages of testing instruction, and the checklist is different between A2, B1, B2, and C1 types of biosafety cabinets. While EN only say that check alarm indicators. NSF have a very methodical smoke test with a very well-defined acceptance criteria, consists of 2 pages of a complete methodical procedure to find problems with the airflow that maybe can't be detected in the airflow test, while EN only states the direction of airflow will be demonstrated by smoke test or other visualization test. NSF have a list of accredited equipment and personnel, technicians, that has improved their ability to certify biosafety cabinets. EN doesn't have. About the extraction system, NSF follow the basic biosafety criteria in the biosafety literature, but EN doesn't have any details about how should be done and allows direct connection. For example, under EN, an A2 cabinet may have a direct connection instead of canopy connection, putting in risk the user and the environment. To remember the biosafety laboratory manual of WHO, the World Health Organization, says that we need a canopy connection to extract the air to outdoors. In terms of the objective or the goal in each standard, we have the NSF, which is very specific in order to establish that the biosafety cabinet must meet the manufacturer specification, and the tolerance are described in the standard. In our hand, EN is very ambiguous If you didn't read the NSF of 1982, you should think that the inflow and downflow velocity must be at least 0.40 and between 0.25 and 0.50 in all cabinets, independent of the design, brand, size, etc. But it's not clear in the standard, and the result that we see every time is always the cabinets are tested following this number. In this graphic is represented the performance of the biosafety cabinets in function of different combination of downflow and inflow velocity. The blue triangle is the microbiological safety zone. There is no escape to the outside, and there is no laboratory air going into the work area. It is taken from the blue triangle, and the set point is taken from a white paper from Baker in United States Manufacturing of Biosafety Cabinets. The red cross is the manufacturer set point. It's in this zone because if you have electricity differences, it's moved in a certain direction. Okay. But this set point is defined with a very strict microbiological test. That microbiological test is in EN and NSF, is in both standards. The black square is the NSF tolerances, and the yellow rectangle without upper limit is the EN tolerance. As we can see, our samples and users are likely to be contaminated, having the cabinet verified under EN standard. Remember, if we have so much inflow, our product fail. If we have a little inflow, a small number of inflow, the personal protection fail, and we can compile with the N in this point, compromising both the product and the personal safety. Okay. What we do test on biosafety cabinets. We do a test to verify that the critical parameters that impact directly on the workers, environment, samples, and public health compiles with the manufacturing instructions, because they demonstrate through a rigorous microbiological testing that in this condition of permanent flow, the biosafety cabinet is protecting workers, environment, and samples. So why we do prefer NSF to the EN? The precision of the methods, well-founded tolerances, repeatability of the results. There are tests that are mandatory in ENSF 49. Downflow velocity profile is very specific. It's an instruction how to calculate the distance between points, the height of the sensor of the anemometer, and there is so much things to have in mind when we perform this test. Inflow velocity test have the all known techniques for take the inflow velocity test, including the direct measurement with barometer, but constricted window and exhaust filter. And for V1 is very interesting how we can perform this test. Testing of airflow patterns by smoke test, leak testing in filter, and site installation assessment, which is alarm testing, interlock test, and performance test of the extractor system. And for A1 cabinets with positive plenum, a cabinet integrity test. It's a test that we need to elevate the pressure in the equipment, and we measure the decay of the pressure. It's very old, it's not usually now. For safety and comfort test, lighting test, vibration test, noise test. And additional test that is required by GMP or some work procedures, particle counting on the air, microbiological control of the air, and microbiological surface control. It's important to avoid using outdated, ambiguous, or technical flaw standard when we have updated standard that reduce the risk of our work and health. Some regulations that are usually mentioned in Spain and Latin America when the annual service is required by the user, but this standard was suppressed or replaced. Some literature directly related to biosafety cabinets and laboratory biosafety. This book has information very important to have in mind when we are working in lab, and especially in this case, information about how to test and install a biosafety cabinet. Okay, I will thank you all for your attention and the opportunity to share my ideas with you today. Thank you. Sorry for my English.
No, thank you very much, Ivan. I understood much more of that than I would have done if you'd spoken it all in Spanish. So thank you. Does anybody have any questions for Ivan on biosafety cabinets? No, you can shout loudly, Alan, but I'll give you a microphone anyway.
Please, the question for beginners in English.
For beginners in English, no worries. From your presentation, I'd be very more worried working in a biosafety cabinet in Europe than I am in the States. Is that a message?
Sorry?
I would be very much more worried working with a biosafety cabinet in Europe than in the States and America. Is that the message? Is it that bad? It seems quite...
Yes. I don't know if I understand, but I respond what I understand. We are working the last years in Spain. I've been working in my company the last 15 years and the last years in Spain. What we see in Spain is a lot of biosafety cabinets that comply with the N, but have contamination of the samples. It's lucky that for now only the contamination is in the samples, or we don't know if a person have contaminated. But yes, what we see is the contractors or the service say you need to replace the filter, you need to replace the cabinet, you need to decontaminate the cabinet, but the problem is airflow too high, or downflow too slow, or inflow 0.65 and downflow 0.25. This is a risk for the sample, but also it's a risk if you have a downflow 0.50 and your inflow 0.41. It's very higher, the downflow through the inflow. I respond your question?
Yeah.
Yes?
Yeah.
Oh.
You interpreted the question correctly.
Yes.
I think, and Alan's sentiment is correct, that how you've presented the comparison between NSF 49 and EN 12469 is that the boundaries of acceptance in EN12469
Yes.
suggest with some of the data you have found in Spain that some biocontainment or biosafety is poor and is unsafe. It sounded what you just explained there
Yes.
was product related, not operator safety related.
Yes.
But that's new information, I think.
Yes.
I have not come across that type of information where EN12469, which has been around for 22 years, it is in revision.
Yes, but when you read the NSF of 1992 and the EN, you read the same but truncated. And the disambiguities of you need to follow the manufacturer numbers disappear.
It's,
And in leak test is important, the difference. Doing the test with aerosol photometers, you can find all the leaks, but we compare with the method with particle counter, and you can have a leak, and for the dilution, you can find that leak with particle counter. In the numbers, the leak doesn't exist.
yeah, I appreciate there are differences. That's why there are two standards. There is not an ISO standard yet for biosafety cabinets. I don't think there will be one very soon either, but there is a destiny, I hope, where NSF 49 and EN12469 will converge. Martin's in the room. AS 1807. Yeah. So I'll bring in. Yeah. So Australian standards are also considered.
Okay.
South Africa adopts the EN12469 into the SANAS standards. So internationally, globally, there are differences in biosafety cabinet standards for testing. But that's interesting and new information that you've shared that shows that some of the performance, the mechanical and aerodynamic performance of the safety cabinet may lead to sample contamination or, at worst, personnel contamination or environmental protection. That's the whole purpose of the biosafety cabinet, is protecting people, product and nature infrastructure. Interesting data that you're sharing.
Thank you.
Does anybody else have a question on this for Ivan? It's sparking quite a debate in my mind, and this is creating something for me to continue a discussion with you after today.
Okay.
Anybody else have a question for Ivan?
Okay, thank you very much.
Thank you very much.